All right, Dan, what do we got going on here?
Well, we're going to investigate Snell's law. We have a light source that's producing a beam of light that is going through this D-shaped lens, and we're going to compare the angle of the incoming beam to the outgoing beam, and the relationship between them is called Snell's law, but you can't see the beam because of the lights. So let's bring the lights down, and then now you can see it. It's going straight in, and it comes straight out. So not a whole lot going on there, but as we rotate it, at some point you can see they're going in different directions. And so we're going to measure the angle between the normal and the incoming beam and the normal and the outgoing beam. And from that, we can derive Snell's law, which is also based on Fermat's principle that the light will take the path of least time from point A to point B.
So what do you mean by least time? Is it's traveling the same speed, right?
So one model would say that the light does slow down when it goes through the lens. And so for the light to go from one end to the other end, if it took a straight line path, that would take it longer than the path it's taking here because it'd spend more time going through the slower medium than the faster one.
Okay. Well, you want to go ahead and make some measurements here?
So how about we start off at...
What are the two quantities that we're going to be measuring again?
The angle of the incoming ray from the normal.
Okay.
And the angle of the outgoing ray from its normal.
Okay, perfect.
And this Pasco basic optics ray table helps us do that. So I'm setting the initial angle to 10.
Okay.
And the outgoing one, well, you may have trouble seeing that on the video, so I'm going to put a pencil by it. Looks like at about 7 degrees to me, but let's bring the lights up so you can see.
Or maybe just...
Or I'll get out of the way. There we go. And so you can see it's at about 7 degrees.
So I'll enter that in our table. So the incident angle was 10 degrees and the refraction angle was 7 degrees.
Right.
Okay.
So let's go up another 15. So the incident beam is at 25 degrees.
Okay, that's already in our table.
And the outgoing one, if I put a pencil there, looks like it's about 16 and a half if you want to go to halves.
16.5.
And now another 15, so we're up to 40.
Okay, 40.
And the outgoing looks like about 25 and a half.
25.5 degrees.
And then another 15.
Boy, it's really starting to bend now.
And we're getting a little reflection off the front, or at least noticeable reflection off the front surface as well. That could confuse you. So now we're at 55.
55.
And the outgoing beam is at 33 and a half.
33.5.
And then one more.
70.
70. You can definitely see that reflected beam now. It's following the law of reflection. And this is the law of refraction. And so it looks to be at 39.
39. Okay, great.
So they have all the data. And so they can do the analysis to do a graph and come up with Snell's law and then use that to answer some of the questions in the lab. And so the rest of the work is for you.